Today we're flying the Inspire 1, equipped with the MicaSense Red Edge camera, which has 5 different bands we're looking at to be able to measure the amount of reflectance coming back from the sorghum plants. In this case, we're looking at plants infested with sugarcane aphid and whether or not we can detect that infestation level from varying altitudes. First things first, we'll get this on the landing pad. So the reason why the propeller's off is for safety. Safety first, as always. So we're going to have to be in close proximity to this while we're configuring the flight plan. But really, we put the blades on once we're pretty close to hitting the launch button. This is actually sending out a Wi-Fi signal. So we're connecting to that Wi-Fi using the iPad in this case. And once we're connected to it, we can configure what altitude and how much overlap, some other factors. But today we're pretty straightforward, 100 meters high with about 75% overlap between images, so that when we do the post-process and we take that back into the lab, the images will have a significant amount of overlap so that there are points to reference so that we can stitch those together and come up with what we call an orthomosaic. I have a significant number of satellites that this particular receiver is connected to, so that each image gets its own GPS coordinates so that we call geo-rectify, or put a coordinate to the pixels so that when we stitch them together, we can put that over on a map, like a Google map that we're kind of used to seeing, and have it make sense. Then I go into my Atlas Flight app on the iPad, and then I'm setting in my flight path. Next thing it's going to ask us to do is it's called reflectance calibration. The angle of the sun is constantly changing, right? It's going across the sky. So the amount of light that's actually reflected back will be changing as the sun is going across the sky. So what we're doing is we'll take a picture pre-flight with a reflectance panel, and then post-flight we'll follow up with another reflectance panel to calibrate pre and post-flight. Simply because even within 7 to 8 minutes, light conditions can change, and when you're talking about sensor data that relies on light, knowing the conditions in which those images were captured, it becomes really important. So right now it's actually flying a much larger area than where our study area is, just because on the edges not all that data turns out to be very good because you don't have a lot of overlap. At 100 meters to get, this is probably got 2 or 3 acres, might only take us 7 minutes. Back down, power off. And then we move on to the next field.